So when we talk about VLANs and trunking, specifically in relation to what we expect to see on the CCIE, the basics and VLANs, basics of VLANs and trunking is really what we're going to take a look at right now. There will be some additional advanced topics like private VLANs and some other components of VLANs that we're going to talk about in later sessions. Right now we're focusing on the basics, and we'll take a look at the command line. We'll use that 4-switch topology that we built in GNS3. And what's most important about this particular section is to talk about the verification steps for basic layer 2 reachability. And the reason why that is so important and so critical is because there's two components on the CCIE lab that you guys are going to have to be responsible for. From the configuration portion of the CCIE lab, of course, this is a basic VLAN and VTP and trunking and access VLANs and whatnot. Those are all considered core topics to ensure that your layer 2 forwarding domain, the data plane in your layer 2 network, is working correctly, because otherwise your layer 3 stuff won't work at all, right? So obviously this is a key piece to that layer 2 data plane reachability. So we're going to take a look at verification steps, basic configuration, and so on. When it comes to VLANs, we obviously have quite a few different concepts that we can talk about. I'm just going to bring up Notepad here just to drop in a couple of notes. When it comes to VLANs, we tend to talk quite a bit about, the different types of VLANs that might exist, right? So you might have your standard VLANs, and we'll talk about the range of standard VLANs, your extended VLANs. How do we create those VLANs? How do we modify them? How do we add them to the database? How do we verify the function of those VLANs? And then we also talk about port types as well. And this is where we're going to spend probably a little bit more time, where we talk about different port types like access ports and what are some of the best practice standards for access ports, 802.1q, trunking ports we will talk about. And finally, what is a dynamic port, and why should I be concerned about dynamic ports in my network, and how can I manage those dynamic ports in the network itself? So these are definitely core topics that you have to understand. When it comes to trunking, we will be talking about protocols like the dynamic trunking protocol. You actually could potentially see scenarios on the CCIE, especially in the troubleshooting section, where they might actually throw, stuff at you that you would assume is already going to work because it's such a basic concept, but they'll catch you, and you'll miss a configuration or you miss a verification because you just assume, well, that's just a basic topic. I don't know why anybody would ever be concerned about that on the CCIE. So the dynamic trunking protocol, we'll spend some time talking about and taking a look at some configurations in that. And then also the 802.1q native VLAN, right? How do we manage that? What are we supposed to do with the native VLAN? And then finally, our trunking allowed list to do our pruning on our VLANs. The core of layer 2 with regard to the scope that you're going to see on the exam is all about data plane forwarding, all right? Now, that doesn't mean to say that there won't be peripheral tasks that you'll have to do in the layer 2 concepts. There are definitely going to be peripheral tasks. It might be configuring port security, or it might be configuring some sort of layer 2 security, end-user facing security mechanism like DHCP snooping or dynamic ARP inspection. But what we're talking about here is complete core functionality. Getting the VLANs to work, making sure that the spanning tree domains are working correctly, because spanning tree is very, very closely tied to VLAN configurations and VLAN operations. All right? Now, VLANs themselves, as you guys are probably aware based on your experience, they fall kind of into different categories. And we already kind of made mention of that. You've got your standard VLANs, which are going to fall in the range of 1 to 1005. And that's all that existed originally, right? In the original versions of spanning tree, the BPDUs themselves only allowed us to identify, because of the size of the field within the BPDU header, it only allowed us to identify VLANs based on these number ranges. And you guys are probably aware that VLAN 1, that's going to be my default VLAN in my database. Let me pull up the command line here. So if I do a quick show VLAN here, actually let me get rid of VLAN 10, no VLAN 10. All right, and I'll do a quick show VLAN, which is, of course, one of the main commands that we use to verify VLAN operations. Just incidentally, guys, this is the topology that we're using for this lab here. And that topology is built in GNS3, and it already exists in the class share for this course. So under the CCIE mentorship, switching topics, LAN switching introduction, lab topology. So the topologies here, obviously because there's no real configuration in this topology, you can, maybe take a screenshot or whatever and build this yourself if you so choose. We're just using the IOL images for the switch itself, okay? But this is the topology that we're using. So I'm in switch number 1, and we're just verifying the VLAN. So VLAN 1 is the default VLAN. Its name is default. And in fact, if I go into VLAN 1, first of all, I have quite a few options with regard to what I can do with the VLAN. And we will get into a lot of these other concepts as we get into some more of the advanced topics, like what is a private VLAN, what can I do with regard to the spanning tree states of this particular VLAN, and so on. But one of the options that you have with kind of standard VLANs is you have the ability to disable those particular VLANs. So if I come in here and I create VLAN 10 and I do a shutdown, I'll get out of my config mode, and you'll notice that VLAN 10 was created in the database, but you can see that it is shut down. If I try to do something similar with VLAN 1, you may have seen that as I did it, you'll get an error that says, you're not allowed to shut down this VLAN because it's the default VLAN. I can't even change the name of the VLAN itself. So a capital D even doesn't allow me to do that. So VLAN 1, we'll talk a little bit later on when we get into VTP about how we can manipulate VLAN 1 to not allow regular data traffic across that VLAN, but only allow your core data plane traffic and your control plane traffic like CDP and VTP. But for the most part, VLAN 1 cannot be shut down, cannot be deleted, and it cannot be pruned, at least manually pruned, from the perspective of data flows. We use VLAN 1 for a lot of control plane functionality. It can't be pruned by VTP, the VLAN trunking protocol. In any event, any method, whether you decide that you're going to not use VLAN 1, you can manually prune VLAN 1 off a trunk link, but that only affects data traffic. It does not affect control plane traffic that's necessary for the VLANs to communicate, okay? However, and we'll talk about VTP in our next lesson, VTP does not allow you to prune off VLAN 1 through the dynamic pruning process. All right. Now, VLAN 1 also happens to be the default .1Q trunk native VLAN. I'll talk a little bit more about the functionality of a native VLAN a little bit later on. But there's a lot of kind of basic stuff that you need to understand with regard to these VLANs themselves. All right. So again, this is not a really advanced topic. It's not something that you guys are probably unfamiliar with, but we will talk about quite a bit when it gets into more of the advanced topics. All right. Couple of prerequisites for VLANs. Before you actually create a VLAN, You have to decide whether or not you want to use VTP, which is called the VLAN trunking protocol, to maintain your global VLAN configuration for your network, or if you decide you want to manually manage those VLANs. If you decide that you want to manually configure the VLANs, but you do not want to enable routing, you might be able to modify the SDM feature on the switch. Unfortunately, I can't demonstrate the SDM feature. You're not going to be tested on it on the exam. It was actually on my CCIE version 4 exam. I had to actually modify the SDM template. SDM stands for Switch Database Management, and that allows you to configure system resources to support whatever function it is that you want to support. So you can modify the SDM template for a switch to provide for more VLANs, or you can modify it to provide for more unicast MAC addresses, or more routing, SVI interfaces and routes and so on. The concept of changing the SDM, because that is a hardware function, cannot be simulated in a virtual environment, and therefore it's not going to be tested on the exam. All right? As I've already started to kind of talk about, there are some limitations with how VLANs, excuse me, I had to sneeze. Sorry about that. There are some limitations and restrictions for VLANs. Now, these limitations will be dependent upon the platform. The number of device per VLAN spanning tree or rapid spanning tree is going to be based on, say, for example, the number of trunks on the switch multiplied by the number of active VLANs on those trunks, plus any of the non-trunking interfaces on the switch. So you've got trunks times your VLANs plus your non-trunking ports. In the case of MST, a multiple spanning tree, the maximum number of supported instances is 4,094. We do have two different trunking mechanisms, ISL, interswitch link, and 802.1q, although I will say that most modern devices only support the .1q trunking method these days. The ability to change, we're going to talk a little bit about SVIs later on, switch virtual interfaces, but the ability to change a virtual MAC address on a VLAN interface is not going to be possible. The interface VLAN already has MAC addresses that are going to get assigned to them by default. I don't know that I really need to get kind of into the specifics of logical networks versus physical networks. I think you guys pretty much understand that. I mean, you guys know that this switch network, that VLANs are logical segmentations, and we can segment our networks based on project team, application, whatever it might be. But a VLAN essentially has the same attribute as any kind of physical LAN, meaning that it's going to allow us to isolate our broadcast domains. It's going to allow us to isolate where traffic can flow through the network and so on. Any device port, access port, can belong to a VLAN, and then you're going to see unicast, broadcast, and multicast packets that get forwarded or flooded, but only to the devices that are in that particular VLAN. So if I come into switch 1 and I do a show VLAN, if a broadcast gets created on Ethernet 3.3, that broadcast is only going to pass over to the other interfaces that are a member of that VLAN. All right. If you have a scenario where you're doing switch stacking, VLANs can obviously be formed with ports across different stacks, and so on. All right. VLANs are managed within the MAC address table as well, and we'll talk about how that MAC address binding to VLAN representation takes place. We'll do a couple of different configurations in our lesson, in this particular lesson. All right. Obviously, VLANs then get associated with different IP subnets and so on. All right. So, like I said, the types of VLANs that your device supports depends on the type of device. For the most part, well, first of all, VLANs are identified from 1 to 4094. So let's talk a little bit about that first. Let me go into MS Paint here and kind of demonstrate something here. So you've got your Ethernet frame, which comes into the switch, and that Ethernet frame is going to look something like this. You might have a preamble, you might have a start of frame delimiter, but the first field within the Ethernet frame is a 6-byte destination address, a 6-byte source address, and then if it's Ethernet 2, which for the most part it is, you've got this type field, which is a 2-byte field. Then you got this 46 to 1500 byte payload field. And then finally you have your frame check sequence, which is a 4-byte frame check sequence. All right? So you have 46 to 1500 bytes to carry your payload, and then you've got your destination MAC, source MAC, type field, and so on. When we're using 802.1q, which is our, oops, sorry about that. When you're using 802.1q, which is our primary tagging method, IEEE specified tagging method, we insert into this frame right between the source address and the type field this 4-byte tag. All right? And that's your VLAN tag. This is what that 4-byte tag looks like. You've got, in the beginning, a 2-byte, oops, let me not do it that way. You got a type field here, which is a 2-byte field, and that's going to be hex 8100. Hex 8100 indicates that this is a tagged frame. And then you've got a 3-bit priority field. Now this is important from the perspective of managing QoS at layer 2. Because if you want to be able to tag your frames at layer 2 and you want to be able to manage QoS, prioritize frames and whatnot, you have to tag those frames. That's what's going to provide you the ability to add this priority field. There's no other encapsulation method in Ethernet that includes this priority field, which gives us classifications of 0 to 7 for the frames at layer 2. So that's one of the good reasons to go through and tag your traffic in the network is because it gives you that QoS capability. So we got 2 bytes here, we've got 3 bits here, and then we've got a 1-bit CFI field, which stands for Conical Format Identifier, which is a token ring encapsulation flag, meaning that we don't use it. But here's the main thing, 12-bit Vlan Field. All right? So within the 802.1q tag, we've got a 12-bit VLAN field, and that 12-bit VLAN field allows me to specify my VLAN. So mathematically, if you go 2 to the power of 12, that equals 4096, zeros inclusive, which means that we're going to have VLANs available to us from 0 to 4095. Does that make sense? So it doesn't matter what the vendor is. It doesn't matter if it's Cisco or Dell or Juniper or whoever else. You're going to be limited to those VLAN ranges. All right? So depending on the type of device, if a device supports VLANs, and VTP and whatnot, VLANs do get identified from this range. Now, you usually will see the range identified as 1 through 4094. And that's because VLAN 0 and VLAN 4095 are reserved for system use. So those are not actual usable VLANs in any case. As I mentioned previously, VLAN 1 is my default VLAN. It gets created during the system initialization. If you look here, you can also see some of the other VLANs that show up, 1002 through 1005. These are my FDDI and token ring, different types of Ethernet encapsulation, encapsulations that are kind of legacy, not really used or don't get used anymore. Okay, so essentially your configurable VLAN range is from 2 to 1001 in the standard VLAN range. When it comes to VTP, which we're going to talk about over the next 2 lessons, there are 3 versions of VTP, the VLAN trunking protocol, version 1, version 2, and version 3. All 3 of those VTP versions support the normal range and extended range, but only VTP version 3 allows you to propagate and support the creation and dynamic management of the extended range of VLANs. So within this concept, so for example, I can come in here and I can put in VLAN 4000, and this switch will allow me to create VLAN 4000. If I do a show VLAN, I can see that VLAN 4000 is actually in the database. If I do a show run, that VLAN actually shows up in the running config. And it shows up in the running config because this is an extended range VLAN, which doesn't get stored in VLAN.dat, which doesn't get propagated with the use of VTP. Okay? All right. We can configure up to, well, it really depends on the device, actually, as to how many VLANs you can actually configure. Let's take a look on this device. If I do a show VTP status, it should tell me how many VLANs I can configure locally. Yep. So it says here the maximum number of VLANs supported on this particular physical device is 1005. That will vary depending on the physical platform. I know, for example, like a 4000 series switch can go up to like 1024 VLANs. All right. Just some basic considerations when we're dealing with our VLAN configurations. All right. So like I said, the properties of VLAN 1002 to 1005 are very similar to VLAN 1 and really should never be used for any kind of individual port assignments. Our extended range VLANs, okay, that's 1006 through 4094, are only used in one of 2 cases, okay? If you're running a switch in VTP transparent mode, we'll talk about that in the next lesson, but if you're running a switch in VTP transparent mode, you can use those extended VLAN ranges. If you're running a switch with VTP version 3, you can run those extended ranges. Important concept here, guys. Keep in mind when I say that, VTP does not define the domain, okay? VTP only allows us to manage the VLAN domain. So if I'm running in transparent mode, I mean, the only choice I have really, other than running in client and server mode, I would just be creating those VLANs manually on the switch. Now you can see in this particular case, this switch is not running in transparent mode, it's running in server mode. But I can come in here and all day long configure some of these extended range VLANs, VLAN 4001, VLAN 4002, and if I do a show VLAN, I can see that those VLANs are being created in the database, well, in the running config, okay? One of the other things to keep in mind, this is a really important concept, and this may be new to you with regard to VLANs. It seems to be that every time I teach this concept, a lot of people didn't realize that this was the case. But some of the extended VLANs are actually reserved for internal usage. Not by default, but as you start to modify the configuration of the device, one of the examples would be converting layer 2 interfaces to layer 3 interfaces. One of the things that you will see is that you start to lose the capability of configuring some of those extended VLANs. I'm going to demonstrate this concept because I think it's really important to understand. The way that we verify what VLANs are reserved for that internal use is we use the command show VLAN internal usage. Now, I don't think that you guys will run into this on the lab. It might be on the written test, of course, but I don't think you'll run into this on the lab. Right now, you can tell from this particular switch that we do not have an interface or a VLAN that's reserved for internal usage at this point. One of the things that will cause that to happen, let me do a quick show IP interface brief. Let's say I wanted to convert interface 3/2 to a routed interface. All right, so I'm going to come into interface Ethernet 3/2 and I'm going to do a no switch port. When you execute the no switch port on an Ethernet interface, it converts it to a layer 3 interface. And if I do a show run interface Ethernet 3.2, you can see that that no switch port command is active, and I also see an option now to be able to put an IP address on that interface. So this is now a layer 3 interface. Now look what happened to my internal VLAN assignments. If I go back to my show internal VLAN or VLAN internal usage, you can see that VLAN 1006 was allocated for an internal process. All right. The problem with this particular process is that not all platforms agree on which external VLANs get reserved for these processes. So you might have one model switch running in one part of the network that's allocating VLANs a certain way, and these VLANs can no longer be used as layer 2 VLANs. Or you might have different switches that do different allocation methods, have different allocation methods. It really depends on the device, and it depends on the software that the switch is running. Catalyst switches, for example, do this completely different than Nexus switches when they're doing the allocation. So one of the things that you need to be familiar with as a network engineer is you have to be able to identify what is the allocation policy for a particular VLAN or these system VLANs that get created. All right, so let's go ahead and take a look at what the allocation policy is on this particular switch, or all the switches in our topology here. So let me first of all go back to interface Ethernet 3.2 and do a switch port. You'll notice that once I've done that, that VLAN that was previously allocated for that internal resource is now released back into the pool, so I can use that VLAN as a regular layer 2 forwarding VLAN for a particular broadcast domain. Okay. One of the commands that you will see in the show run is this VLAN allocation policy option. VLAN internal allocation policy is presently set to ascending, okay? Which means that it's going to start at the very first VLAN that's available within the extended range, and it's going to start assigning or allocating those VLANs individually as you add more and more layer 3 features or other types of features to this particular platform. So you can actually change that method. If I come in here and I say VLAN internal allocation policy, I can specify that I'd rather have that policy be descending instead of ascending. So now if I go back to interface Ethernet 3/2, I do a no switch port, well, let's go ahead and get out of there. I can see that it started at the top at 4094, and it's now allocating VLANs in a descending order rather than an ascending order. The problem that you run into is if you do a show VLAN, you will not see that VLAN allocated in the show VLAN output. So you might say, well, I'm going to go ahead and use VLAN 4094. So I'm going to try and create VLAN 4094. Once I get out of the database, you will see that it throws an error. Failed to commit the extended VLAN change. All right, the VLAN is in use. It's in use by Ethernet 3.2. Failed to create the VLAN. So unless you were aware that this was something that occurred as part of the internal process of a Cisco switch, you might be banging your head against the wall trying to figure out what the heck it was that that they were trying to accomplish, or you know, why can't I create this VLAN, right? I should be able to create this particular VLAN. All right. Now, there are a couple of other things to keep in mind when it comes to creating VLANs. There's a legacy method for creating VLANs, and there's more of a modern method for creating VLANs. In global config, that's really considered the modern method, but you can actually modify the VLAN database directly from exec mode. If I go in here and I type VLAN database, I can modify the, well, it would be ASE, but I can modify the let me get out of there. I can modify the VLAN database by simply typing VLAN database. Notice my prompt changed to switch 1 VLAN. This is kind of unique as well because what you're actually doing is you're modifying a database. You're not just modifying the running config or the startup config, you're modifying a database that directly exists within Flash called vlan.dat. So you can see there's several different things that we can do. My question mark didn't work there. But I can add a VLAN 10, VLAN 20, VLAN 30. I can delete a VLAN, no VLAN 30. And then if I hit apply, I can apply those changes to the database itself. Now I can come in here and do a show spanning tree, VLAN 20, and you can see that spanning tree is now running on VLAN 20. It's running on VLAN 30. I deleted 30, sorry. It's not running on 30 because VLAN 30 doesn't exist. All right. Spanning tree, believe it or not, even though it's a completely unrelated concept, well, I wouldn't say completely unrelated, but somewhat disconnected from the concept of configuring VLANs, spanning tree is a great way to verify the functionality of your layer 2 domain. You know, to be able to identify whether or not that layer 2 domain is going to be forwarding on the data plane or not. If you don't have an active spanning tree instance for your layer 2 domain, then obviously the layer 2 domain traffic is not going to work. All right. So we need to make sure that we have a spanning tree instance that exists. Now, it is possible that you may have a VLAN configured, but the spanning tree instance wouldn't exist. Any thoughts on where that might occur? Where I've created a VLAN in the database, but there is no spanning tree instance for that particular VLAN. Well, go ahead.
Maybe if it was designated as a non-switch port.
Well, certainly on an interface, the VLAN might not exist, and I think I know what you're referencing is why a switch port might not show up in a particular VLAN. Let me see if I can demonstrate it on this. In our topology here, we have Ethernet 2021, 1011, 00, and 01. So what I'm going to do is I'm going to go ahead and just shut down on switch 1 all those interfaces because those interfaces are configured as trunks, and that means that they're automatically going to pass traffic for all the VLANs. So I'm going to do a quick interface range Ethernet 0/0 dash 3, 1/0 dash 3, I guess I'll do 2/0 dash 3. Oops, I forgot my Ethernet. All right, and I'm just going to do a shutdown. So I'm shutting down all those trunk interfaces. And if I do a show VLAN, you can see that I've got VLANs 10 and 20. Well, VLAN 10 is shut down. Let me go ahead and turn VLAN 10 back on. Oops. All right, so I've got VLANs 10 and 20 listed here in my VLAN database. If I do a show spanning tree VLAN 10, you can see that the spanning tree instance does not exist for VLAN 10, even though VLAN 10 is in the database. So that was the question I posed, is why, if the VLAN exists, why would the spanning tree instance not exist for that particular VLAN? And the answer is because that VLAN is not active anywhere on the switch. Does that make sense? There are no access ports that are assigned to that VLAN, and my trunk ports in this case are shut down, so there's no trunk ports that are passing traffic for that particular VLAN. Maybe if I create interface VLAN 10, let's see if that changes the concept. Show spanning tree VLAN 10. Negative. All right. Well, that makes sense, doesn't it? Because technically the SVI is a layer 3 concept. Spanning tree is a layer 2 protocol. So the only way that you can effectively get a VLAN to function is if you have that VLAN assigned. So if I go into interface Ethernet, let's see. Let's do a show IP interface brief real quick. So Ethernet 3.1, right? So I go into interface Ethernet 3.1 and I say switch port access VLAN 10. So now the VLAN is active on a layer 2 interface. And if I do a show spanning tree for that particular VLAN, then I can see that the VLAN is now, or spanning tree instance is now active for a particular VLAN. The main thing to take away from this concept here is that if there is no spanning tree instance for a particular layer 2 VLAN, you will not be able to forward traffic for that VLAN, regardless of the reason. So one of the quick troubleshooting techniques that you can have, even though you may not directly be troubleshooting spanning tree, is to make sure that you have a spanning tree instance for a particular layer 2 forwarding plane, right? Or a layer 2 domain. In this case, VLAN 10. All right. The other thing is that, especially when it comes to spanning tree, everybody should really agree on what that spanning tree topology should look like. And if for some reason, either through a manual pruning process or some sort of bogus VTP pruning process, a VLAN gets stripped off or removed from the database, logically, then the spanning tree instance gets removed and you're not going to be able to forward traffic for that particular VLAN. All right. Now, the reason that I had brought those interfaces up or shut those interfaces down is because in this particular instance of GNS3, let me bring those guys back up real quick. Let's do -3 here. The reason that I brought this up is because, or shut these interfaces down, is because I wanted to demonstrate this concept that the spanning tree instance does not get created unless the VLAN is active. If I do a show interface trunk, you can see that in fact Ethernet 0001, 1011, those are all of the interfaces that are going back and forth between my switches, 0001, 1011, and 2021, because these switches are configured to run ISL. Actually, they're configured to run, ISL. Well, they're running DTP. We'll talk about that in a little bit, which ends up negotiating those links to be a trunk. And of course, because VLAN 10 is in my database, VLAN 10 is going to be allowed across that trunk port. All right? We can create a VLAN by simply assigning a VLAN directly to an interface as well. It doesn't work 100% of the time. It depends on what the VTP mode is. Let me explain what I mean. So if I do a show VLAN, let me kill VLAN 10 and 20. No VLAN 10, no VLAN 20. And you guys are probably aware of this. If I go config T, interface Ethernet 3/1, switch port access VLAN 100, right? So it says, well, VLAN 100 doesn't exist. I'm going to go ahead and create it for you. As long as the switch is running in transparent mode and or server mode, this is okay. This is going to work just fine. However, if I change my switch, and we'll talk more about this in the next lesson, to client mode, and I go into interface Ethernet 3.1, and I type switch port access VLAN 101, notice it doesn't say creating the VLAN. And it also, by the way, doesn't give me an error. All right, so I might think that VLAN 101 existed, or I might think that VLAN 101 was created, but if I do a show spanning tree VLAN 101, you can see that VLAN 101 does not exist, even though it might be assigned to the interface. Show run interface Ethernet 3.1, we can see VLAN 101 is assigned to the interface. So client mode VTP we'll talk about a little bit later on, actually in the next lesson. But one of the restrictions of client mode is that you cannot create VLANs locally. You have to learn the VLANs through the VTP process. All right. The other option that we have is, let me change this guy back to VTP server. No VTP mode client. As to create VLANs consecutively. So I can say, okay, I want to do a VLAN 50 and 60 and 70 through 76 or 75 and VLAN 100 and 101. So you can actually create VLANs in a group by using the comma and the dash as your separator to identify those particular VLANs. All right. A port on a switch can either be a layer 2 port or it can be a layer 3 port. And by default, the ports on the switches are going to be layer 2 ports. But there are different options for how the port acts as a member of a particular VLAN. So we can configure a port to belong to a VLAN by assigning it using the membership mode that specifies the kind of traffic that port is going to carry. Static access is one of the options. And I'm going to demonstrate some of this stuff a little bit later on. But a static access port can belong to only one VLAN, and that's one that gets assigned manually to the port. In this particular case, if I'm running static access, there is no need for VTP. Now, in VTP version 1 and 2, you don't have the ability to actually shut down VTP or get rid of VTP. But you can effectively disable VTP by running VTP mode in transparent. All right? We'll get more into the VTP discussion a little bit later on. So that's one of the options I have for my interfaces, is to make them a static access port. Another option I have is to make it a .1q trunk port. IEEE 802.1q is our industry standard trunking encapsulation, and a trunk port is a member of all VLANs by default, even the extended range. But we can limit the participation in particular VLANs by configuring something on the trunk port called an allowed VLAN list. I'll demonstrate this in a minute. We can also modify what's called a pruning eligible list if we want to block flooded traffic to a particular VLAN on trunk ports that are included in that pruning eligible list. That's part of the VTP discussion, which we'll get into a little bit later on. The only other type of port that might exist is the voice VLAN port, what we call the auxiliary VLAN port. It's an access port that's attached to a Cisco phone, and we set that up by using an auxiliary VLAN. Let me demonstrate that real quick. Let's say that there's a phone connected to port 3/2. Let me go into show run interface Ethernet 3/2. So right now 3.2 is configured as a routed port. I'm going to leave that. Let's do 3.3 for now. Okay. So let's say on interface Ethernet 3.3, I've got a phone connected, and that phone is in VLAN 50. All right. I'm going to assign that auxiliary VLAN to this interface by using the switch port voice VLAN command to assign VLAN 50 to that interface. All right. Now notice if I do a show VLAN 50 exists because I created it during that process where I was demonstrating the different ranges that we could add. I can also assign switch port access VLAN, let's call it 60 in this case, for the data VLAN. So this is the exception to that golden rule that you can only have one access VLAN on an access port. Because if I do a show run, interface Ethernet 3/3, you can see that it actually has two different VLANs assigned. It's got an access VLAN and a voice VLAN. If I do a show VLAN, we only see Ethernet 3/3, but we see it for both VLANs. So it's, you might look at that and go, well, wait a minute, how can that port be a member of two different VLANs? But obviously, one is an auxiliary VLAN. All right. On the ingress, the auxiliary VLAN is assumed to be tagged. So the phone that's connected to the switch port is going to start tagging the traffic that goes over to the switch before it gets to the switch, whereas the PC traffic will be untagged, or if the PC is tagging the traffic, then the phone can be configured to untrust that PC and remark that traffic, with a appropriate DSCP value or class of service value, whatever it is we're trying to assign. All right. All right. Now, as far as where the VLANs are stored, there are a couple of different places in the switch where VLANs get stored. Configurations for VLANs 1 through 1005, those get written to the VLAN database, which is called the VLAN.dat file. If you do a show VLAN, that's essentially what you're seeing is that the contents of that VLAN.dat file. The VLAN.dat file is actually stored in flash memory. I can't show you it here because this device doesn't actually have flash. It's a virtual router. All right. If you're running VTP in transparent mode, the VLAN information is going to be stored in the running configuration file, not the VLAN.dat. And you can actually move back and forth from one mode to the next. So say, for example, if I do a show VTP status here, I can see that I am presently running, that's weird, do show VTP status. I'm presently running in server mode. I've got 15 different VLANs that are configured, 8 changes to the database. And if I do a show run, you won't see any indication of those VLANs existing here, with the exception of the extended range. The standard range you won't see. All right? So let's go ahead and switch to transparent mode, VTP mode transparent, and do a show run. And now you will see that all of the VLAN information shows up in the running config as opposed to being stored in VLAN.dat. So I can now go and delete VLAN.dat from my flash, and the switch will operate normally. And you can switch back. If I'm running in transparent mode and I come back here and I say VTP mode server, whatever is configured inside of my running config for my VLAN information will then get propagated back into VLAN.dat as part of the VLAN.dat configuration. Okay? All right. When you save the VLAN information and the VTP information, including the extended range VLAN configuration information, in the startup config file and you reboot the device, the actual device configuration follows a particular step when it's loading. All right. If the VTP mode is transparent, in the startup config and the VLAN database and the VTP domain name from that VLAN database match what's configured in the startup config, the VLAN database is actually ignored. In fact, it actually gets cleared out. The VTP and the VLAN configuration in the startup config is what's going to be used when the device boots. If the VTP mode or the domain name in the startup configuration file does not match the VLAN database, the domain name and the VTP mode and the configurations for VLAN 1 through 1005 use the VLAN database information. So there is a potential for conflict there, right? Where you think that one thing is going to happen, but another thing happens because you don't have a synchronized database. In VTP version 1 and 2, which we'll talk about in the next lesson, especially in server mode, the domain name and the VLAN configurations for VLANs 1 all the way up to 1005 use the VLAN database information. And then we can extend that functionality in VTP version 3 because VTP version 3 supports the extended VLAN range as well. You guys, this is like CCNA 101, but if you're installing a new switch on the network, make sure you delete the configuration by doing a write erase and make sure you delete the VLAN.dat file because you have a huge potential of overriding VLAN information in other switches if you don't do that. Okay? Let me think if there are some other guidelines. The normal range, yeah, 1 through 1005, we talked about that. 1002 through 1005 are reserved for token ring and FDDI. We can modify VLANs 2 through 1001, VLAN 1 and 1002 through 1005. Those are automatically created. They can't be removed. We can exclude, in the extended VLAN range, as long as they're in transparent mode, we can create those VLANs as well. Now, VTP version 3 supports the propagation in server mode of those extended range VLANs, but VTP version 1 and version 2 doesn't do that. Okay? All right. One of the limitations that you might run into is the ability to manage traffic flow in multiple VLANs. If the device supports 128 spanning tree instances, that means that you can have 128 active VLANs. If for some reason you have more VLANs than are supported based on the number of spanning tree instances, spanning tree can be enabled on those 128 VLANs, that maximum value, but it can also be disabled on other VLANs. I don't recommend it. I think that opens yourself up to a huge vulnerability, but it is possible. Okay? So one of the other options that we have when it comes to VLANs is we can remember these or learn these VLANs through the propagation of VLAN configuration information by other switches through the use of VTP. And even though you're most likely not going to have to set up or configure VTP as part of the process within the CCIE lab, you'll certainly be tested about VTP and the concepts of VTP as part of the overall process of doing like your diagnostics and your troubleshooting and so on, but within the context of the written exam, not the lab exam. A trunk port within, in regards to VLANs and VTP, a trunk port is any interface that has to carry traffic for more than one VLAN. Doesn't matter how many VLANs it is, but if you have more than one VLAN that has to pass across a link, that is considered a trunk port. The trunk port actually encodes the VLAN number in the data plane to allow it to identify what VLAN that particular traffic belongs to. It does that encoding using 802.1q. You can also do tunneled switch ports. It's something called 802.1q tunnel layer 2 VPNs, but we don't really talk too much about tunneled layer 2 VPNs in this class. It's not really part of, it's more part of the CCNP security track. And then we can also run a protocol called the Dynamic Trunking Protocol, or DTP. There are two modes of operation that DTP support. DTP supports auto mode or desirable mode, where interfaces can negotiate whether or not they're going to become trunks based on this dynamic negotiation or these DTP messages that are going to be passed back and forth between the different interfaces. 802.1q, as you can probably guess, is an open standard protocol. The native VLAN on the trunk interface itself is never tagged. We can actually change that behavior. There's a command that we can use. I don't think it's supported in this iOS, but there's a command that we can use to actually change the behavior of whether or not the native VLAN is tagged across the trunk or not. But I do want to talk about a little bit about DTP and the Dynamic Trunking Protocol and how we can manage the DTP process and even identify some of the potential vulnerabilities that you're going to see with DTP by taking a look at one of the interfaces on our switch. So let's take a look at Ethernet 2/0. If you guys already have the lab built, you can kind of follow along or you can just watch. But if I do a show run interface Ethernet 2.0, you can see that it really doesn't have any kind of configuration on the interface. It's just a basic configuration. The port is enabled. It's running full duplex or automatic duplex, where it's doing a duplex negotiation and speed negotiation. But if I do a show interface Ethernet 2.0 switch port, one of the things that I want to point out, let me try that again. Do show interface Ethernet 2/0 switch port. Let's try it without the do this time. I'm not in config mode. Oh, come on. Show interface Ethernet. There we go. All right. So show interface Ethernet switch port. This is one of the key verification commands that you want to make a note of that will allow you to verify your layer 2 core configurations. But the port is enabled. But you'll notice that this particular administrative the administrative mode of this port is dynamic desirable. And the operational mode is as a trunk. So this is how the port is configured. And this is how the port is operating. And just because the port is configured to negotiate to become a trunk doesn't mean it will become a trunk. Because if I'm connecting to another interface that is configured statically as an access port and isn't programmed to respond to DTP, then the port will negotiate down to the access layer, or as an access port. We can see the administrative trunking encapsulation is to negotiate. So we're going to negotiate our trunking protocol. Presently, this particular interface identified that it wanted to use ISL. Believe it or not, ISL would be preferred over 802.1q on switch ports that actually support both, or switch interfaces that support both, even though ISL is kind of a substandard protocol. Negotiation of trunking is turned on. This directly relates to the dynamic trunking protocol. The access mode VLAN, if this port was an access port, the port would go into VLAN number 1. The trunking native VLAN is VLAN 1. And then we've got some other, there's no voice VLAN configured and there's no private VLAN configurations on this particular interface. So this interface is running DTP. Now there are two modes of DTP that exist. We can run DTP in auto or we can run DTP in desirable mode. If you do switch port mode dynamic auto, that's the command that I would use. It doesn't work in GNS3, but that's the command that I would use to establish that the port is auto. Or I do switch port mode dynamic desirable. Those are my options. Desirable. This particular mode, the port sends and accepts DTP messages. And this port only sends DTP proactively, only sends DTP messages proactively. All right? So, or it will respond to DTP requests as well. Reactively to a DTP request. So if you have a port, you have one port that's dynamic auto, and another port on the same link that's also dynamic auto, then the port will revert to an access port, because there's nobody on that link that's trying to negotiate to become a trunk. All right. If you have auto to desirable, then the interface will become a trunk. Oops. Guess I should probably get away from using Notepad, and learn how to type. If you have desirable to desirable, that will also become a trunk, because both sides are proactively trying to negotiate the interface as a trunk. Okay. If you have trunk to auto, now this one's a little bit unique because a lot of people are not necessarily aware, and I'm going to demonstrate this in a second. In fact, let me do that now. Let's say I go into Ethernet 2.0, config T, interface Ethernet 2.0, and I say switch port mode trunk. All right. Oops, I got to set the encapsulation type. Switch port trunk encapsulation.1Q, which you have to set on switches that have support multiple encapsulation types require you to set the encapsulation type before you can statically configure it as a trunk. So if I say switch port mode trunk now, and I come in here and I do a show interface Ethernet 2.0 switch, switch is short for switch port, you can see that the negotiation of trunking is still enabled on this particular interface. All right? So even though I've hard set the port to a trunk, I can see this here. The administrative mode is trunk. The operational mode is trunk. Even though I've hard set this port to trunk, the negotiation of trunking is still turned on. Okay? So in that particular case, that means that a trunk to an auto port can still become a trunk because the trunk port is still sending DTP messages, so we can negotiate that interface as a trunk. You should not use DTP. Why is that? Tim, I'm sure you're aware, but why would I not want to use DTP in my LAN environment? Any thoughts?
You can break some stuff.
Because you can break the stuff? Yeah. Well, I guess that's a good answer. I can accept that.
If you want a trunk, you're going to set up a trunk purposely. You don't want to just have some. Also, you don't want to have somebody put something in and then suddenly be able to siphon off your.
Yes, exactly, and that's really the key, right?
From a security perspective, it opens you up for somebody being able to come in and do equivalent to a managed node.
Right. Right. Sorry I interrupted you there. You're absolutely right. We have a saying in the engineering world, if it's auto, it means you ought to not use it, right? And you can't get away from that 100%. But anything that's automatic by nature is susceptible to attack. I mean, you think about all the weakest protocols that you have in networking, and it's ARP and DHCP and DNS and all these other protocols that are dynamic by nature. The problem with DTP is that the default DTP mode on nearly 100% of our switches is either auto or desirable, right? Now you might say, well, wait a minute, those are the only two modes. Well, off is a mode as well. You can disable DTP and that would be considered a mode. So all I have to do is plug APC into a DTP-enabled port and start generating my DTP messages. There is a protocol called Yersinia. I mean, a protocol, an application called Yersinia. It's part of Kali Linux that some of the later builds of Kali Linux, and Yersinia provides you the ability to generate DTP messages. Well, guess what? If I can generate DTP messages, I can force an interface to become a trunk. And now I can start doing a VLAN hopping attack by tagging frames and sending those frames to multiple VLANs. But it gets worse than that, because VTP runs over trunk links. And if I can somehow make an interface a trunk, I might be able to influence your VTP domain as well. Maybe I can overwrite your VLAN database, or get a copy of your VLAN database, and so on. And we'll definitely talk about the weaknesses that exist in VTP when we get to that particular piece there. So there is a command that you can run. Now, if I go into an interface, let's say interface Ethernet 3/0, for example, and I say switch port mode access, do show interface Ethernet 3/0 switch port, you can see that this interface is statically configured as an access port, but automatically DTP gets disabled on that interface. And that's the reason why you would run the switch port mode access command. It's not to make the port an access port, because a port that doesn't negotiate DTP, just simply because it doesn't get DTP messages, will automatically revert back to an access port anyway. So you can assign a VLAN to an interface without statically disabling DTP, and that port can still be an access port. So if you run switch port mode access, that's going to disable that DTP functionality on that interface. The other option you have, let me see, I keep forgetting what interfaces we're dealing with here, is, let me go back to 2.0. First of all, I'm going to take off the static trunk configuration. I want everything to be consistent here. So interface Ethernet 2.0, no switch port mode trunk, no switch port trunk encapsulation .1q. All right. There's another command, and unfortunately, it's not really supported in GNS3. It's the command, and I'll just have to type it out here, switch port no negotiate. Now, it doesn't work, but switch port no negotiate is a command, and you would actually have to make the interface a trunk first before you could execute this command. The interface cannot be, the interface itself cannot be a dynamic interface in order to do the no negotiate. But if I execute the command switch port no negotiate, that also disables DTP on a trunk interface. It's not as much of a security risk on a trunk interface to run DTP because it's already a trunk. So we're not necessarily concerned about whether or not somebody can plug a rogue device into that interface and make it a trunk. But as a best practice standard, you should definitely consider disabling DTP on your ports, because you're just, it's either a protocol that's not necessary, or it's a protocol that's going to introduce quite a few vulnerabilities in the configuration of your device. All right. Switch port mode, actually you can see here we actually have a few options. Not too many on this switch here, but if you did switch port mode, let me try and spell it right, switch port mode, you can see that you do have some options, right? We can make this a private VLAN port, a .1q tunnel for layer 2 VPN tunneling, an access port, a trunk port. But you also might be able to see switch port mode dynamic. In some modern switches, you would see an additional command there, or subcommand there called dynamic, where you could actually say this is a dynamic desirable or dynamic auto port. All right. Another way to verify the trunks on your devices, because we're talking about VLANs and trunks in this particular lesson, is to do a show interface trunk. Pretty straightforward output here, but there are some specifics that I think are important to understand. Obviously, if you run the show interface trunk command, you should see all the trunk interfaces on your device. Be clear though, this will only show interfaces that are active trunks. Even though an interface may be configured as a trunk, if the interface status is not up, then it will not show up in this list. Okay, because the port has to be active in order for it to show up in this list. We can see that in this particular case, all of these interfaces are desirable, meaning that they're actually sending DTP messages and they're negotiating DTP. They reverted to the ISL encapsulation method and is negotiated ISL. The interfaces are presently trunking and the trunk native VLAN, which means the traffic that does not get tagged over the interface is in VLAN 1. Now, after that, you're going to see three different sections here. You're going to see, and we'll talk about this more when we get into VTP, but you're going to see the VLANs that are allowed on the trunk, the VLANs that are allowed and active in the domain, and then finally the VLANs in spanning tree forwarding state and not pruned. So let's say, for example, VLAN 20. Right? If I do a show spanning tree VLAN 20, you will see that there is no spanning tree instance for VLAN 20, even though VLAN 20 is allowed across the trunk. But VLAN 20 does not exist in the database. It needs to exist in the database in order for a spanning tree instance to be created. Well, actually, let me rephrase that, because we already demonstrated this. Even though a VLAN might exist in the database, doesn't mean it's going to be in a forwarding state. It's not going to have a spanning tree instance if it's not assigned anywhere. Now, in our case, if I did create VLAN 20, right, and I do a show interface trunk, you will see that VLAN 20 is active in the domain, all right, and it's active on this particular interface, VLAN 20. It's not active on these ports yet, but it did show up eventually, or it will show up eventually in this state as well, okay? So if I do a show spanning tree VLAN 20, you can see that it's definitely, there is a spanning tree instance for this particular VLAN now, because by default, the VLAN gets added to the trunk. So if I do a show interface trunk, eventually I'll see that it is in the spanning tree forwarding state and not pruned. Why did it show up here so quickly, but it took a while for it to show up in this bottom list? Do you guys have any idea? Why did it show up in that middle section, but didn't show up in the bottom section for a little while? The key here is spanning tree forwarding state. We're using the 802.1d variant of spanning tree, which is PVST plus, per VLAN spanning tree plus on the switch, and it takes about 50 seconds for a VLAN to go in a forwarding state in that mode of operation, because we're running the D stands for don't use this version of spanning tree, 802.1d, which takes a little bit of time to go through the listening and learning states before we finally end up in the forwarding state. So just because a VLAN is allowed and active, that means it's created in the database, doesn't mean that it has a spanning tree instance or it's being forwarded in spanning tree. Now watch what happens when I prune VLAN 20 off of my trunk interfaces. So I'm going to go config T, interface range, Ethernet 0/0-1, comma Ethernet 1/0-1. Is that right? Yeah. Comma Ethernet 2/0/1-1. And I say spanning tree VLAN allowed. Spanning tree allowed VLAN, excuse me. What am I saying, spanning tree? Sorry, switch port trunk allowed VLAN. Now I can actually add the VLANs that are active, like VLAN 50, 60, 70, or whatever. but I can also just do accept 20, right? So this is a process called pruning the VLANs off the trunk. And we would do this if we didn't need that VLAN traffic to go over the trunk because it's kind of inefficient. If there's nobody on the other side of that trunk that needs to see a particular VLAN, then you would prune it off. A prime example of this would be when you're connecting your switch to a VMware server and you've got hypervisors running on that VMware server, and that VMware server link is a trunk because you've got multiple hypervisors running on that machine. Well, if you don't prune off VLANs, then all of the unbounded unicast traffic in a VLAN or all of the broadcast traffic or multicast traffic in a VLAN will go over that link even though the VMware server doesn't need to see that particular traffic. So we can prune the traffic off of our trunks by using the switch port trunk allowed. And you can see you can add, you can do all, you can do accept, you can do none, you can remove a particular VLAN from a trunk. So I could come in here and I can say, okay, I want to go ahead and remove 50. All right. Now, if I do a show run interface Ethernet 00, all right, you can see how the command got structured based on the fact that I said, I'm going to allow everything except for 20, and then I removed 50. Maybe, of course, I could have said except 20, 50, but I was just trying to demonstrate how we could otherwise remove a VLAN from the trunk. So now if I do a show interface trunk, you will see that even though VLANs 50 and 20 exist in the database, they're not allowed across the trunk. They've been pruned. They're not allowed or active in the management domain, and certainly there would be no spanning tree forwarding instance for those particular VLANs. All right? So it is a best practice. It is possible on the exam that they might, I've seen this before, where like in the troubleshooting exam, they're filtering off VLANs that effectively break your layer 2 connectivity. So make sure that you use the show interface trunk command to verify the operational state of your trunks and what VLANs are going to be allowed across those trunks and so on. All right. Let's see, what else do we want to talk about? If you decide to disable DTP negotiation on a trunk interface, I wish I could demonstrate this, but I can't. We use the switch port no negotiate command for that. If you want to disable DTP negotiation on a trunk interface, you have to configure the encapsulation method and you have to configure the trunk option on the interface first. You cannot do a switch port no negotiate on a dynamic port, meaning that it's not defined as access or not defined as trunk. So it kind of makes sense though if you think about it. Okay. So we already talked a little bit about the issues that we run into if we're running DTP on our ports. And the idea of DTP was good in essence, that Cisco wanted that the switch trunk configurations to be dynamic so that it was plug and play. And traditionally, the distribution layer type switches would be running DTP in desirable mode, and the access layer switches would be running DTP in auto mode. But the problem is that the trunks could not negotiate. I mean, the trunks would get negotiated there, but you have that vulnerability. So on your trunk ports, we disable DTP by typing switch port no negotiate. And on our access ports, we disable DTP by typing switch port mode access. You can also disable DTP if you make it a .1Q tunnel for layer 2 VPN tunneling as well. That command, I believe, is switch port mode .1Q-tunnel, which doesn't exist in this version of software. Again, if you want to verify whether or not DTP is running on an interface, show interface switch port. Okay? We only have a couple more things to talk about in this lesson, and then we'll take a quick break, and then we'll go into our final lesson for the evening. But as far as manually pruning your trunks, All VLANs, like I said, are allowed across the trunk interface by default. If I do a quick show interface trunk here, we pruned off Ethernet, well, all of them actually. Let me go into interface Ethernet 2/0 and say switch port trunk allowed VLAN all. Do show interface trunk. So you can see that by allowing all VLANs, then all VLANs are going to be allowed. And those VLANs eventually will show up as active in the domain, and that traffic will pass over those trunk links. The only downside that I've run into in a production environment when I'm dealing with, and by the way, you might run into this in the CCIE, where you forget that you're doing manual pruning of your trunk interfaces, and you decide to add a VLAN to your enterprise later on down the road, but you've got 4 or 5 or 6 or 7 different switches in line. You forget to deprune that particular VLAN on one of those links. So your layer 2 data plane is broken in that case. Okay. We have the allowed list. The allowed list, like I said, we can exclude particular VLANs, we can add VLANs, we can remove VLANs. Show interface trunk will, of course, show us what's configured. You really do, as a best practice, want to limit the amount of broadcasts. If other switches don't need to see traffic for a particular VLAN, you should definitely prune those VLANs, okay? The bottom line, I guess this is kind of the takeaway from this whole discussion, is one of the most important things that you need to verify when you're going through the lab and you're doing your layer 2 connectivity, your core configuration, not the ancillary pieces that you have to configure, is make sure your VLANs are active in the appropriate domains. Okay? The show VLAN or show VLAN brief command, show interface status. In fact, let me put this in Notepad because we're kind of summarizing the lesson now. All right? Important commands. This will be something that I'll try to do at the end of a lot of different lessons, is kind of identify some of the important commands, not configuration, but verification and troubleshooting. Show VLAN, of course, and you might even have the brief option there. Okay. Show interface status. Let me show you that. I didn't show you that command. Do show interface status. The nice thing about this command, which I'm sure you guys have seen before, it's a quick way for us to identify the state of an interface. Is it a trunk? Is it a routed interface? If it's an access port, is it assigned to a particular VLAN? How is the speed and the duplex negotiated, and so on? So show interface status gives us a quick breakdown of which interfaces are routed, which interfaces are trunks, which interfaces are access ports. And then, of course, which interfaces belong to which VLANs. Let's see, we had a question here. Another gotcha. If you forget to add a VLAN to a trunk, you can accidentally remove the existing VLANs and only add the one you're adding. That's absolutely correct. Thank you for pointing that out, Mike. If I'm going into an interface and I say switch port trunk VLAN, allowed VLAN, and I say 10, that automatically removes any of the other VLANs that were already previously added. So you would want to instead use the keyword add 10 or remove 10 or whatever it is that you're trying to accomplish. And I mean, you'll find out pretty quickly if that happens, but definitely something to consider. Okay. Some of the other commands that are very useful in this part of the discussion, show interface status, like I said. Definitely a command that you want in your tool chest when you're going into the lab. Very, very quick way of verifying the information. Another way you could do this, and this does work on the test in the lab, well, the configuration pieces in the lab, you might do, say, for example, a show interface status with a grep command. So you might say, for example, I'm going to go ahead and grep, include all the interfaces that are not connect, right? Meaning that these are the interfaces that are not physically connected. Show interface switch port, I showed you guys that one. Good command for verifying really a whole bunch of things about the interface. Show interface switch port works for trunks as well as access ports. And we can see if DTP is running. If it is running, how did the port get negotiated? What are the private VLAN configurations? What's the native VLAN configuration? What's the trunk encapsulation method? You know, all kinds of stuff, all right? Show interface trunk. All right. And even though it's not really part of this discussion directly, we already saw that show spanning tree VLAN or interface can be very useful for identifying whether a VLAN is being forwarded in a particular instance. Because if the VLAN is not active or the VLAN is not configured, even though it might be in the database, doesn't mean necessarily that it's actually in a forwarding state, in spanning tree, okay? One of the classes I had, we had a question about router on a stick and whether or not, if I have router on a stick configured, whether or not the control plane traffic in router on a stick is carried over VLAN 1 or whether it's carried over a different VLAN. So let me kind of go through a scenario here. Let's say I have a router. That router is connected to a switch, and then I might have another router here, and these interfaces here are trunks. So we have sub-interfaces on the routers. Maybe it's sub-interface Ethernet 0.1, and over here Ethernet 0.1, okay? Well, when I'm doing, say, OSPF between these two routers, obviously we use hello packets to establish the adjacency between those two routers. Well, if that OSPF configuration is tied to sub-interface Ethernet 0.1, one of the things that's happening on that interface, that sub-interface, is Ethernet encapsulation. Okay, so those OSPF datagrams are going to be tagged into, so you got your DA, you got your SA, you got your tag, you got your type, and then you have your OSPF payload, and you have your frame check sequence. So even the OSPF packets, those control plane packets that allow us to establish the adjacency, they're going to get tagged with the whatever .1Q tag is tied to the sub-interface on the router configuration. So even though we're running a trunk and the native VLAN does exist on that trunk interface, VLAN 1, from a switch's perspective, all that OSPF traffic is just regular data traffic, so it's going to be tagged appropriately. Okay? All right. Now, there are, by default, VLAN 1. A lot of people ask me about VLAN 1, and, I can't shut down VLAN 1, I can't delete VLAN 1, I can't rename VLAN 1, but how could I avoid using VLAN 1? My concern is that VLAN 1 is not tagged. There is a command you can run. It's not supported in GNS3, but there is a command you can run to force tagging to occur on your native VLAN. And it's the VLAN, let me move down here. VLAN, this is done in global configuration mode, .1Q tag. All right. Actually, you have to add the word native as well. That will tag all of that VLAN 1 traffic across the trunk if you wanted the tagging to occur. It doesn't work on our switches, or else I demonstrate it. The native VLAN is extremely important. If the native VLAN is misconfigured, we can break the control plane for spanning tree, but we can also have process issues with the data plane forwarding as well. Generally speaking, the best practice with the native VLAN is to simply make it a VLAN that's not used in your enterprise. It's a VLAN that's configured in the database, but it doesn't go anywhere. All right? I'll talk a little bit more about that later on when we get into some of the other best practices for configuring VLANs. Okay? CDP runs on VLAN 1. VTP runs on VLAN 1. You can prune VLAN 1 off of an interface. For example, let's say here I go into interface Ethernet 2.0 and I say switch port trunk allowed all except, let me do allow VLAN allowed. Sorry, VLAN all except, I don't think it lets me do that. Let me do this. Except 1. Okay? So if I do a show interface trunk, you'll actually see that VLAN 1 looks like it's been pruned off of Ethernet 2.0. The reality is we've minimized the function of VLAN 1 on Ethernet 2.0. It's actually technically called VLAN minimization. We're doing VLAN 1 minimization. It's still going to allow for the control plane traffic. All right? Things like VTP and CDP will still run over the link, but VLAN 1 data traffic will not be allowed over that particular link. Okay? All right, well that concludes that lesson. I had scheduled 2 hours for it. It took about an hour and a half, so that's good. Do you guys have any other input, comments, concerns, questions about the basic VLAN and VTP stuff? We will eventually get to a point where we're kind of building a topology and we're adding these configurations to that topology. But I think this stuff, for the most part, is pretty basic, and I think you guys probably already had a pretty good understanding about this. Maybe the internal allocation piece you might not have been aware of, but for the rest of it, you probably were aware of it. Okay? All righty. Is there any kind of follow-up reading to this? Well, if we go into your switching topics or the mentorship program, in there's this the CCIE Routing and Switching version 5 volume. And if you go into the LAN switching, there's obviously a couple of chapters that I suggest that you read. Probably not going to be any different than what you already saw with this lesson, but the VLANs and virtual trunking chapter is definitely a good chapter to take a look at after this particular lesson. This is kind of the Bible for studying for the CCIE. So this going back and reading this section here can be very, very useful for kind of solidifying a lot of your knowledge. Remember, it's all about muscle memory. You got to be able to do everything quickly. Now, one of the topics that's covered in here is private VLANs. We're going to cover that a little bit later on as part of another discussion, but private VLANs, something that you're most likely going to have to know on the exam, but that's kind of strange. That page was missing some stuff. All right, but not so much on the lab. All right, we'll talk about community ports and isolated ports and promiscuous and host ports and so on, but that's a good section to kind of go through. All right. As we get into some more of the advanced topics, I will definitely have more reading and more documentation that you guys will have to take a look at. So we're going to go ahead and wrap up this particular lesson. We'll take a break, just another 5 or so minutes, and then we will get into the next lesson for the day, which is VTP version 1 and VTP version 2.